Hello, everyone. Welcome to the second unit of the class. We're going to start talking about physical sciences, so matter, energy, and geology, as you can see. And so this is going to include chemistry, some physics, and obviously geology. Let's go ahead and get started and take a look at the goals for this week. The first goal, explain the fundamental laws of matter in chemistry. So we're going to take a look at some of the laws of thermodynamics, what matter is, what an atom is, and so on and so forth. We're going to differentiate between different forms of energy, such as potential, kinetic, and then within those two types of energy, we also have chemical, mechanical, and many other types of energy. We're going to distinguish between photosynthesis, cellular respiration, and chemosynthesis. And we're also going to look at the importance of these processes to life on Earth. Next, we're going to look at plate tectonics and the rock cycle and how that shapes the world around us. And finally, look at geological hazards and describe certain ways that we can mitigate the impacts of those hazards. So let's go ahead and get started with the periodic table. Everyone has seen this before. It should look familiar at least. We're not going to go into too much detail in the periodic table as far as what makes something a metalloid or a transition metal. If you're curious about that, then obviously go ahead and dig a little deeper into the periodic table, or even better, take a chemistry class, right? But for this class, we're going to focus on the basics. So, periodic table of the elements. Well, what is an element? You ever stopped and asked yourself that question? What makes something an element? Well, there's actually a really good definition for it. And that definition is a chemical substance with a given set of properties that cannot be broken down into substances with other properties. Basically, what this means is that if you take a big hunk of carbon, for example, and you break it down into smaller chunks, those smaller chunks of carbon don't become a different type of matter. They're still carbon, right? Moving on, or continuing with our carbon analogy, we'll talk now about what an atom is, because atoms are the smallest unit of matter that contains those chemical properties of the elements that we're talking about. A lot of times you'll hear an atom described or defined as the fundamental unit of matter. I'm no physicist, I'm not a particle physicist or anything like that. I know there are smaller particles than atoms, but atoms, such as a carbon atom or a hydrogen atom, these are the smallest units that display stereotypical behaviors. And they're definitely the more useful to biologists and chemists, right? If you string two atoms together, could be the same element or of different elements, you get a molecule. So atmospheric oxygen that we breathe, is two oxygen atoms stuck together. So an atom is a single unit of that element, whereas a molecule may be two or more. And you can also have multiple elements in a molecule as well. Here is a carbon atom. And what we're looking at is the constituent parts of that atom, because as you already know, there are smaller units than atoms, but we usually stop there for biological purposes. So let's look at those particles just so that we have a better sense of what makes up an atom, so that when we talk about bonds and the way atoms behave, we'll have a better understanding of why. So this is a carbon atom. If you go back to the periodic table, you'll see that carbon has an atomic number of 6. That number refers to the number of protons in the nucleus of that atom. Here is the nucleus of an atom. You'll notice there are 1, 2, 3, 4, 5, 6 protons. That's what that atomic number represents. Also in the nucleus, you'll see these white particles. These are neutrons. Notice neutrons do not have a symbol here. That's because they are not charged. They are not positively or negative charged. They're neutral. So in the nucleus, you have 6 protons as well as 6 neutrons. On the outside of the nucleus, you'll notice that there are negatively charged particles called electrons. In this case, there are 1, 2, 3, 4, 5, 6. So a carbon atom, a typical carbon atom, is going to have 6 protons, 6 neutrons, and 6 electrons. Yes, you heard that right. 6, 6, 6. I always think that's kind of funny, but it's just the reality that we live in, is that most life is composed of carbon. And carbon has 6 protons, 6 neutrons, and 6 electrons. But let's go ahead and move on and talk briefly about an isotope. So not all isotopes are radioactive, but what an isotope is an element or an atom of an element that contains a different number of neutrons than normal. So normally, a uranium atom has 92 protons, and we can go back to the periodic table right. Find uranium on here, bam, and we can see how many neutrons it normally has. You basically take this number here, 238, subtract 92 from that, to 146. So let's go back to our uranium slide, and you'll see that sometimes you can have fewer than that, 143 neutrons. So this is a normal uranium atom. This is a type of uranium atom, an isotope of it, that contains 143 neutrons. And this is the kind of uranium that we usually use for nuclear energy. It's easier to split apart, which releases lots of energy, and that energy can then be used to heat water, which will turn a turbine and generate electricity. This is a methane molecule. Notice we have carbon, hydrogen, I have 4 hydrogens. This is a molecule instead of an atom because it's made of 2 or more atoms. But what I really want to show here is bonding. So in this case, carbon is bound to 1, 2, 3, 4 different elements. The reason carbon can bind to 4 different elements is because it has only 4 electrons in its valence shell. An element is most stable, or an atom is most stable when it has 8 electrons in its outermost shell. It can only hold 2 here, but in the outermost shell it can hold 8. Carbon has 4 electrons normally in its valence shell, which means it can add 4 more. And that's why it can bond to 4 other molecules. This is also why carbon is so important to life, because it can form such a diverse array of molecules because of the number of bonds it can form. There's several different types of bonds in chemistry. We're going to talk about 3 mainly. The first one here is an ionic bond. This is a bond where one atom donates an electron to another atom forming a bond via opposite charges. So this is a lithium atom. This is a fluorine atom. You count the electrons in the valence shell here, you'll see, remember that valence shell is the outermost shell of electrons. You'll see here, though, that there's only 1 in lithium. Whereas in fluorine, there are 1, 2, 3, 4, 5, 6, 7. Atoms want to balance their valence shells. They want them to be full meaning they want them to have 8 electrons. Or if you're a smaller element, your innermost shell can only hold 2. So 2 is the maximum here. So having 2 would be stable. So when lithium and fluorine are close together, lithium will often donate this electron, bam, to fluorine, giving it an extra electron. Fluorine, that is, will have the extra electron, whereas lithium will now be without an electron. Electrons are negatively charged, so when you gain an electron, your charge actually goes down. Your charge becomes negative. We also call this an anion, A-N-I-O-N. When you lose an electron, you're losing a little bit of a negative charge, so your charge goes up. You become a cation, C-A-T-I-O-N, cation. There's lots of ions in nature. So here's some cations here, these positive ions: hydrogen, H+, sodium, silver, potassium, lithium, there's the one we just talked about. Here's some molecular ions, ammonium, and there's also nitrate, but that's a negative ion, an anion, right? So chloride, bromide, fluoride, iodide. And if you look at the periodic table, you'll find that most of the positive ions are at the left side of the periodic table, and a lot of the negative ions, or the elements that form negative ions, are going to be on the right side of the periodic table. And I'll let you kind of ponder that, and maybe you can figure out why that is. I'll give you a hint. It has to do with the number of electrons in their valence shell. The next type of bond is a covalent bond. Valent, that's referring to that valence shell. This is a bond that is formed when electrons are shared between atoms. In this case, hydrogen, which has an atomic number of 1 proton, actually no neutrons in a hydrogen atom, and 1 electron. Atmospheric hydrogen almost always exists in this state, where one hydrogen atom is bound to another, forming a hydrogen molecule, or molecular hydrogen. So each of these shells has 1 electron in them. By sharing 1, now they have 2. That's a stable valence shell.